Thank you, Malcolm. I'm delighted to speak this morning to such a large audience and to be on the same platform as Clinton Cayley of Shell and the Minister, the Energy Minister, Fergus Ewing. Yes, I'm going to talk and focus on Subsea and the contribution of Subsea technology to UKCS exploitation now and in the future. So I'll give you a little bit about the industry here, the kind of projects we're doing where we're extending limits, some involvement by ourselves, you could say Wood Group Kenny, the Subsea part of Wood Group, give you our perspective, but also projects outside of that. And let's look over a little bit over the fence and see what our neighbours are doing in a similar basin, just to give us a bit of insight there and draw some conclusions. Glenn already touched on this. We've a 6 billion business here in the UK, which is nearly a third of the world's subsea market. So our status and our share of the world market is significant. It continues to grow 40% in the last 3 years, and growth is both in the export and domestic market, with North Sea dominating, with 56% of our output exported annually. This was an extensive survey done on our industry by Subsea UK earlier this year, and these are just some of the results of that. We employ 40,000 people directly. You can see that the distribution there in the blue and purple between manufacturing and services is quite significant. But again, in the global context and in the international context, Subsea is set to grow in the next 5 years by 100%, and we sit to try to get a share of that. And even within the UKCS, I think we're maybe about 45–50% of current production through Subsea wells, and that's predicted to grow through 70%. So we've a very significant industry here in Subsea, and a growing one. And you know, here's the Quad 204 project, the redevelopment of the Schiehallion field, where BP are looking to extend the life of this field to 2035, predicting that they'll ultimately have production of 1 billion barrels, a hugely significant project for the UKCS, with up to 50 new subsea wells, bringing the total count to 100 eventually, with new infrastructure, trees, rises, flow lines, etc. I mean, if we're talking about exploiting the North Sea and maximising the return on that, what a project to demonstrate here on our very doorstep that this is exploitation at its best. And I'm delighted to say that we've been, as Wood Group Kenny, significantly involved in this development. But it brings the thing about floating production, and we look back to 1989, the Ivanhoe Rob Rye floating production systems, one of the early floaters in the North Sea, and we realise, of course, that this is also a subsea development, and subsea and floating production are closely linked. And we continue today to develop new projects, new floater projects with new subsea developments. And here in the North Sea sector, all our floater developments are utilising subsea technology. It's good as well just to look at the international perspective. I show you here the Girasol project development in the west of Africa, came on stream in 2001 in about 1,300 metres of water. Actually, you had a new riser system, and the relationship between riser systems and floating production is very important. This was a hybrid, top-tensioned riser, a new development. So it started off, it was similar at its time. It was a good project, and has many projects now in west of Africa going into even 2,000 metres of water with bigger number of subsea wells, etc. So lots of developments there. But of course, in a couple of years here in the west of Shetlands, we'll have the new Rosebank project, which will be in over 1,000 metres of water in probably what is the harshest environment around the world. So that in time will no doubt be a world-class project here on our very own doorstep. And keeping on that theme, you've got Total's Lagan Tormore project, planned on stream in 2014, 143 kilometres tieback from two subsea wells, Lagan and Tormore well centres, by 18-inch production lines back to Sullom Voe Terminal. And it'll come on stream before Rosebank, so it will indeed be the deepest subsea tieback in the North Sea, and is setting records in terms of the tieback distance and the harsh environment. So another groundbreaking project. I guess all of us here in the room have seen our business grow. As Wood Group Kenny, in terms of our subsea business, we're now 2,500 people worldwide, with with 500 people, over 500 people here in Aberdeen and another 380 down in London, where we're executing probably 10 to 15 subsea feeds per annum. I won't go through all the list there. You have various projects in the North Sea and elsewhere, but as I say, Quad 204 I mentioned earlier, and I thought was notable as well is that we're intimately involved in the Subsea Well Response Programme, which has been led by Shell on behalf of the European side post-Macondo in terms of, sort of well control and containment and that kind of stuff. So very interesting projects indeed. So just going back a little bit, and here's another Shell project in Penguins, which came on stream in 2003. We're actually looking at the redevelopment of it now. But at the time, this was a fairly innovative development in terms of high pressure and high temperature. And in terms, the pipeline there is actually 65 kilometers from the wells to the platform. It's not shown to scale there. But at the time, it was the longest tieback in the North Sea. And indeed, in terms of a pipe-and-pipe technology for this high-pressure, high-temperature field, was the world's longest pipe-and-pipe. And it brought in some new design methodology in terms of probabilistic burst design, limit state design, and for expansion of pipeline and buckling, snake lay, and stuff like that. So it brought in some new innovations. And just to keep things in terms of context, in terms of tieback distance, in the early 90s, the Troll-Usberg at 48 kilometers, with Mensa in the Gulf of Mexico extending to 110 kilometers, and you can see right up to the present day where Lagan Termore is right up there with Snøhvit at one of the longest subsea tiebacks in the world. So we're continuing to extend our reach, and this is all about exploiting North Sea developments. The BP Rum field was also in 2005, and we were involved in it, and we're involved in the design. It was hailed as the North Sea's most significant recent tieback development. Again, higher pressure, higher temperature. It wasn't the first one, but one of the early applicators of what we call the HIPS pipeline protection system, whereby effectively you protect that tieback pipeline from the higher pressures of the reservoir, therefore enabling you to be able to successfully design that tieback distance. And that HIPS will have an important effect going forward as well. And just some of the lists of projects that we've been involved in down the years within the high temperature, high pressure region, either high temperature or high pressure. You see that we've got some good experience in that. I think it's also important, I just picked the Andrew Devenick one, and I think what I really wanted to focus on here, if we make tieback into existing infrastructure, connecting that back into the platform is important. And that caisson design, that caisson shown in slightly yellow-orange there, if you like, on the platform, is outside the platform initially, coming back inside the jacket in the wave zone. But being able to bring up multiple riser pipes and umbilicals, so effectively allowing, being able to do that tieback. And we've got extensive experience here. And indeed, that project as well had some notable things in it, because we daisy-chained 3 pipeline bundles as we connected in the pipeline system tieback into that platform. So I think in terms of evolutions, I was talking to some of my colleagues, we were talking about transportation systems. We're trying to transport fluids from the reservoir to the platform and up onto a floating platform, for example. So flexible risers have played a great role in floating production and continue to do so. But in terms of pipelines, as we've had ever harsher flow assurance environments, first of all, we've brought in reel lay, we've had pipe-in-pipe and pipeline bundle, and we're even now, and I'll talk a little bit more about that, heating pipelines at the moment, some more developments there. In terms of control systems, we've got the HIPS developments, which is for high pressure, high temperature developments, but it would also allow us to daisy chain in new subsea tiebacks with higher pressure requirements into maybe a lower pressure field, because we could protect the lower pressure field with the HIPS. We've done a lot in terms of communications and control with the introduction of fibre optics for communication and monitoring of our subsea system, some significant developments there. And more recently on Total's K5 project in the Netherlands, the installation of an all-electric tree, because really, to a large point today, we're using electrohydraulics from the platform, and so we want to reduce those umbilical costs by taking out the hydraulics and going all electric. And this is a significant new recent development. And we're in boosting. boosting in terms of electrical and hydraulic submersible pumps. The Otter development came on stream in 2002. It was the first time we installed dual ESPs into the reservoir, electrical submersible pumps. It was a 21-kilometre tieback, so it was an important project at the time and had a significant contribution into extending the life of the Shell Eider platform. So that same theme of getting more out of the North Sea. As I was saying, we're now looking at heating pipelines, direct electrical heating. Somehow we get a current into the pipeline, we convert that electrical energy into heat, we raise the temperature in the flow line. That means we can have more difficult flow assurance, longer tiebacks, mitigating against wax and hydrates. And direct electrical heating has been used certainly in shutdown and startup conditions to mitigate these effects. But a more recent development, that is the total Islay development, I think, which is quite significant, came on stream this year. It's a pilot project. It's the world's first application of electrical heat pipe-in-pipe systems. And we've got the simultaneous, if you can see from the diagram on the bottom, we've got the simultaneous application of heat tracing on the pipe, inside the insulation, making it very effective, and fibre optic cables to monitor temperature. And in fact has much less power requirements, 10 times less, than the direct electrical heating I showed you earlier, which means we can now think about continually heating our pipelines, continually and resolving difficult flow assurance problems, extending those tieback lengths and getting more difficult reservoirs. And this technique, thing has been developed by Technip in collaboration with Total, and you can see I've got a Technip photograph there of the concept. But I mean, we talked a little bit about collaboration and things like that. But one thing you see in the North Sea is a variety of approaches. There's no real standard approach to doing subsea tiebacks. We have the long-established operators there, and we have, for example, and we have small to medium operators, and they operate in slightly different ways. And indeed, in terms of our work, we have to be able to do that. But even within the bigger operators, like you take, for example, BP, they have two approaches to developing greenfield projects as opposed to brownfield projects. So even they recognize that you need different approaches to get these things done. And indeed today, many of our projects have brownfield element in it. Subsea is even playing a role in redevelopment of abandoned platform fields such as the Northwest Hutton, which will be at Darwin, a new tieback. But we talked about Glenn talked about lower cost subsea, and for sure I think there's evidence that we're bringing down the time from initial discovery to development. I mean, many years ago it might have been 3 years. We're now 12 months is achievable in terms of how we do things. I noticed as well, Statoil last year presented a presentation how they're grouping small projects together. They're talking about standardization of equipment and moving that faster. So there's maybe an initiative in terms of how we can move subsea tiebacks quicker. But of course we still focus on tried and tested technology. Perhaps we could be a bit more innovative sometimes, but that's an issue. And operators have different approaches to the supply chain also. But now I'm just going to look over the boundary a little bit and look at our colleagues in the Norwegian sector. And one thing that's very clear when you look at that is the emergence of subsea processing. And for me, the significant investment in the development, testing, and qualification of subsea processing equipment. I'll come back to that point earlier, but let's look at this Tortoise separation project in 2007, where essentially I had a mature field with a lot of water content. Why do you need to be pumping that water up into the platform? So let's separate out that water, let's inject it back into the reservoir, and then the remaining fluids through a pump boost them back up to the platform. And this is an improvement initiative, because what Statoil are saying is they're bringing their coverables from 49% to 55%, and for that field, an extra 35 million barrels of oil. But coming to my point about the testing of equipment, looking at the Ormen Lange pilot, which is a full-scale subsea processing and compression system, and they're going to do 2 years of testing on it. It's a large test beat, 36 meters long, holding 1,000 tons of equipment. This is a fairly significant equipment, a significant investment in this kind of new technology. and Aker Solutions are involved there with Statoil in that. So that stands out quite a bit. If you look at the Asgard project, similar type of idea, now looking in to put in gas compression and liquid boosting. Essentially, compress the gas, that gives it energy, boost it back up, and push the liquids by pumps. So boosting and compression. And the issue here is that the reservoir pressure is dropping, therefore you're not getting stable flows and you have reduced recovery. So by installing such a system, Statoil say that they're going to increase the volumes to 280 million barrels of oil equivalent. Again, an improved oil recovery project. And now we see that technology going internationally with the application of those kind of technologies in west of Africa in Total's Pazflor project and Brazil in Petrobras Marlim's project. And indeed, Statoil have this vision of the Subsea factory where we put more of the processing equipment down on the sea floor, including indeed, as you can see from that diagram, subsea storage. Another initiative, and Glenn mentioned this about the well intervention, that indeed it seems we're only intervening on 17% of our wells. Well, Statoil have been quite proactive, if you like, in stimulating the industry to bring in new tailored vessels for well intervention. And I show Aker's Aker recently launched Aker well intervention vessel. So they've gone into this idea of categorizing the vessels according to whether they're A, light intervention, right up to drilling and completion. And with 500 subsea wells that they have in the Norwegian continental shelf, they're looking now forward to a very proactive program of intervening on subsea wells to get that recovery. And indeed, we're kind of getting ready for that ourselves. One area we're really looking at is fatigue, and it's an industry issue at the moment. Fatigue at the wellhead area, on the subsea wellhead area, critical stresses within that wellhead as you work over and intervene on it. And the solution here, as we see it, is the combination of monitoring at key locations on a riser and tying that into a riser model that's able to predict almost online the fatigue at the critical locations, including down there at the wellhead. So this will be a contribution. We work together with Fugro on that one in terms of that whole subsea well intervention thing. I think I would just make one other comment, and that is in terms of operations and integrity, because Glenn came on to this point as well, and you can see the pictures that represent that there in terms of risk assessment, how much, what should you be doing, or looking at a subsea pipeline inspection. Many UKCS projects are being extended, have been extended, more will be extended, and there's lots of potential for life extension. Knowing your current integrity status is one of the key things to trying to understand how you can extend that life, among other things. One thing I would say, that one initiative that we're working together at the moment is at Woodgruppen is we've launched this, it's been going now for about a year and a half, the SURF Integrity Management Joint Industry Project. Indeed, it's run by ourselves and launched through the Industry Technology Facilitator here. And it's supported on an international basis by 12 operators. And we've been working over the last number of years. We've been sharing information within the group. It's an operator only one at the moment, but we've been bringing in the supply chain. And we've been looking at inspection technology, both existing inspection technology and emerging technology. We're looking to produce guidelines. We're looking to move into a phase 2 of that, where we see how we can develop some of those technologies. So I think in the subsea world, we're certainly understanding the importance of subsea integrity and how we can extend life. And indeed, in the broader sense, I know the Oil and Gas UK has been here in the North Sea looking at the specific thing in relation to controls and control equipment and subsea obsolescence, and operators have got together looking at that. And indeed, the Energy Institute have produced some guidelines in relation to how you plan for obsolescence. But I do think, and we are seeing a change in behaviour. We're seeing a change in behaviour. We're seeing it in the work that we're doing in terms of feed and concept design, whereby operators are asking us to think about integrity right up at the start. How do you build inspection capability, monitoring capability, integrity capability into your design right from inception? And hopefully some of these initiatives will contribute towards that change in behaviour and approach. So what I would conclude is that subsea technology is making a very sizable contribution towards further exploitation and elongation of the UK continental shelf, and will contribute and continue to do that into the future. You know, we're working on our pipeline and transportation systems. We're developing the technology which will allow us to have longer subsea tiebacks, look at more difficult reservoirs, higher temperatures and pressures, longer, deeper and cooler tiebacks. That's happening. I hope you can see that from some of the things I showed you today. Subsea processing is now really emerging as a viable, improved recovery rate solution for our sector. The question I would ask, though, in terms of some of the things I gave you about Norway is, it seems to me that there's a very coordinated approach, at least in the subsea field, as to what the vision for the future is. And I wonder, have we lacked that here in the UK? And is that likely to harm our long-term leadership position in subsea? And secondly, when I think of subsea processing, you know, have we been slow to adopt this? And why have we been slow to adopt this? Because really, what's the difference really between our basin and the Norwegian sector? So perhaps some provocative things to finish with. Thank you very much indeed.